All right. So if P of X is a polynomial, right? Then, and suppose C is a zero of the polynomial, P of X. We also say that C is a root or a solution, right? When P of X is equal to 0, right? Similarly, once you know that C is a root or a solution, then the factor theorem said that X minus C is a factor. All right? And similarly, we can also say that C comma 0 is an x-intercept. All right? So this is how all of this is related. If C is a 0, it's also an x-intercept, it's a root, it's a solution. And X minus C is a factor of P. So here, why don't we solve this equation and state the number and type of roots. The first one is a quadratic equation. So to solve, I'm just going to factor it in quadratic form. And here I'm looking for two numbers that multiply to negative 48 and add to 2. X minus 6 and x plus 8. So x is equal to 6 and x is equal to negative 8. Negative 8. So what does this tell me? How many solutions do I have? 2, and they are real. Okay? All right, well, what about this one? How can I factor x to the 4 minus 256? Right. And then you can factor this, so x minus 4, x plus 4, that cannot be factored. It's irreducible. So now I have that x equals 4, negative 4. From here, x squared equals negative 16. So what's x equal to? Plus or minus 4i. So how many solutions do I have here?
You have 2 real.
I have 2 real and 2. Right, they're imaginary or they're complex. Okay? All right. Now, let's talk about the fundamental theorem of algebra. Well, this says that every polynomial that has a degree greater than 0 has at least one root in the set of the complex numbers. All right? So every single polynomial that has a degree greater than 0 has to have at least 1 0. And that 1 0, and those zeros are either real or imaginary or complex. Now here's a corollary. If a polynomial has a degree of n, then it has exactly n roots. All right, including roots that are repeated. So if a polynomial is a degree 7, then it's got to have 7 roots. Some of those are real, some of those are imaginary. They're all real, they're, mixed and so on. Some might be repeating. Okay? Yes.
And if it has...
Okay, so here's Descartes. Remember, you guys know Descartes? Descartes' the one, first of all, to whom we owe the Cartesian coordinate system with the x-axis and the y-axis. He's a French philosopher and mathematician. He's the guy who said, I think, therefore I am, if you've heard of that. So Descartes' rule of signs, he came up with a system for us to be able to determine exactly how many positive real roots something has and how many negative real roots something has. Okay? All right, so how do we find it? To find the number of positive real roots, you basically look at P of X and you see the number of changes in sign of the coefficients. All right? And then you take that number and you keep going down by 2s. I'm going to do an example. To look at the number of negative real zeros, you find p of negative x, and you look at the number of times the coefficient changes sign. All right, so let's do an example. All right, so here it says find the possible number of positive, negative, and imaginary roots for this polynomial, and we have to put it in the form of a table. All right, so p of x is this polynomial that we're just given. In order to get the number of positive roots, I take p of x, and now I need to look at how many times the coefficients of p of x change sign. So the first coefficient for negative x to the 6 is negative. From there, it changes to positive, right? All right, so from negative, it changes to positive, and then it changes to negative again, and that's it. So how many times does it change sign? Twice. Now, Descartes says 2 is the largest number of positive zeros. However, what you do is you take that number and you keep subtracting from it increments of 2, right? So if you take 2 and you subtract 2, what do you have left? 0. So it's either got 2 positive zeros or 0 positive zeros. In other words, suppose instead of 2, we counted the number of sign changes and we got 6, right? Then it would have been what? 6 or 4 or 2 or 0. Now, suppose we didn't get 6, we got 5. It would have been 5 or 3 or 1. All right? You keep subtracting increments of 2 until you can no longer subtract 2. The number of negative roots, what we're going to do is we're going to now look at p of negative x. Okay, so for the first time, I'll write it out and then we'll see a pattern. P of negative x means to make all the x's negative. So this is negative x to the 6 plus 4 negative x cubed minus 2 negative x squared minus negative x minus 1. That means p of negative x is negative x to the 6 minus 4x cubed minus 2x squared plus x minus 1. So you can't just switch the signs because you're making x negative, and depending on what the exponent is, the sign may or may not change. Now, let's examine this a little bit. I'm making all of the x's here negative, right? Now, if you take a negative x and you raise it to an exponent that's even, what happens to that negative? It becomes positive, it goes away. If you take a negative x and you raise it to an exponent that's negative, what happens? It stays negative. So look at the first term. You have negative x to the 6, right? It's got an even exponent, and the result, it remains unchanged. Negative x to the 6, negative x to the 6. Look at the negative 2x squared. It remains unchanged. Which ones do switch sign? The ones that have odd exponent. The 4x cubed changes sign. The negative x changes sign, right? So when you're doing this again, the next time, you don't have to write that intermediate step. You could just switch the signs of the negative, of the odd powers, and you're done. Okay? This is how we do it in the honors.
So odd changes in the order.
So p of negative x, how many times does p of negative x change sign? 2. Why 2? Oh yes, 2. 1, 2. Right? So 2 or 0. Now I need to take all of the possibilities. I'm running out of on our batteries, Maya. What is it? So there could be 2 or 0 positive roots, 2 or 0 negative roots. Now we have to take all the combinations. However, we first have to know what is the total number of zeros. How many zeros does this absolutely need to have, this function? 6. We know that because this number, the degree is 6, so it's got to have a total of 6. All right, now we're going to make a chart. Positive, negative, imaginary. All right, now, it can have either 2 or 0 positive, right? Now, so basically, what I'm doing is this. So for the positive, it's either 2 or 0. For the negative, it's either 2 or 0. And now I need to take every possible combination, right? So if it's got 2 positive ones, it could either have 2 or 0 negative ones. Now, look at the top row. If it's got 2 positive, 2 negative, that's a total of 4. How many does that leave for imaginary? 2. For a total of 6. You see it? If it's got 2 positive, 0 negative, how much does that leave for imaginary? 4. Now, if it's got 0 positive, it could have 2 or 0 negative. All right, so if you have 0 positive, 2 negative, how many imaginary? 4. And if you have 0 positive, 0 negative, how many imaginary? 6. All right, so each row has to add up to the degree. What's the condition for this column? It has to be what? All even, right? Because these are imaginary numbers, and they always come in pairs. So these have to be multiples of 2.
How about if there's like 3 positives? Oh yeah.
There'll be 3 positives, 1 negative. Yeah. Yeah. Okay, we're gonna do one more, but this time I haven't broken it down into the steps. So the number of positive roots, right? We look at the sign changes in h of x, and the coefficients change once there and once here. So it's 2 or 0. Now, for the negative, I want to look at h of negative x. Okay, I'm going to switch the sign of all the ones that have odd exponents. So negative 2x to the 5th, positive x to the 4, negative 3x cubed, negative 4x squared, plus x plus 9, right? Now, how many times does this change sign? 1, 2, 3. So for the negatives, it's either 3 or 1. So now let's make our chart. Positive, negative, imaginary. And again, I just want all the combinations. What should each row add up to this time? 5. Okay. So it's either 2 with 3 or 2 with 1. Or it's either 0 with 3, 0 with 1. Now, you have to take 1 purple with each of the blue. 1 purple with each of the blue. Okay? So now, in the first case, how many is that for imaginary? 0. Second one, third one, and then 4. All right? And they're all even or 0, so we're good. Okay? That's your answer. The chart is your answer. The chart is your answer. All right. Now, how do we find the zeros? Well, we have now a variety of techniques to find the zeros, right? Let's start narrowing down our list. Okay. Descartes' rule of signs, right? Let's use Descartes' rule of signs to find the numbers and the types of zeros. So, how many positive zeros are there? A possibility of 1, 2, or 0. How many negative? Well, let's see. F of negative x is negative x cubed minus x squared minus 2x plus 4. So how many? Just one. Up. It's just one. So there is definitely a negative 0, right? So the possibility is it's either got 2 positive, 1 negative, or 0 positive, 1 negative. This is a simpler case. And in the first case, how many imaginary? 0. And in the second case, 2 imaginary. Okay? All right. So let's use a table of values. All right. So I'm going to plug this in. So I have in y equals, I'm going to put in x cubed minus x squared plus 2x plus 4. And let's look at the table. So you see in the table, there is a 0 at negative 1. Are there any other zeros? No, right? So which of the options does it look like it's going to be? It looks like there is 1 0 at x equals negative 1. That's a negative 0, right? And it doesn't look like there are any others. So it looks like it's going to be this option, right? And the rest of them are going to be imaginaries, right? So there is a 0 at x equals negative 1. Now, to do the rest manually, right? Because I now know that it's not going to be on the graph, okay? That means it must be an imaginary. What we're going to do is identify the depressed polynomial. What does that mean? What process? Synthetic division. All right, so I just found my first 0 at negative 1. I'm going to use that to get my other factors and then to find the zeros. So here I put my coefficients, 1 minus 1, negative, positive 2 and 4. 1 comes down, I get negative 1, negative 2, positive 2, 4, negative 4, 0.
How did you find that 0?
I looked on the table on my calculator to find that 0. Okay, so here I get that f of x is equal to x plus 1. And from here I get x squared minus 2x plus 4. All right, so how do I get the zeros? I have to set f of x equal to 0. The first one I already know gives me x equals minus 1. Can I factor the other?
No.
I already know it's going to be imaginary, so I don't even look at the whole factoring possibility. So let's use the quadratic formula. Negative b plus or minus b squared minus 4 times a times c all over 2. So this is 2 plus or minus 4 minus 16 is what? Negative 12 over 2. 2 plus or minus 2I root 3 over 2. So x is 1 plus or minus I root 3. And here x equals minus 1. And there you have them. One last one here. Complex conjugates. All right. A complex conjugate is when you have a plus bi. A complex conjugate is the same coefficients, but when the imaginary part changes sign. So a plus bi becomes a minus bi. Meaning, suppose you have 2 plus 5i. What would the complex conjugate be? 2 minus 5i, right? We've done this before, right? If you have negative 2i, what would the complex conjugate be? Positive 2i. If you have 7, what's the complex conjugate? Just 7. It's only for imaginary parts of the complex numbers. Now, we already said that imaginary numbers or imaginary solutions come in pairs, right? Meaning, if 3 plus 4i is a solution, you automatically know without having to be told that its complex conjugate, 3 minus 4i, is also a solution. When you're given a complex 0, you're only given 1. They never give you 2 of the pair because it's redundant. So you take the one that they gave you, and you yourself know that there's supposed to be another one, and you add it in. Okay? Now, here, this problem says, write a polynomial function of least degree. So the lowest possible degree that it could have, with zeros which include 4 and 4 minus I. All right? How many zeros are you given? You're given 2. But there is a third one. What's that third one? 4 plus I. Right? So what's the degree of this polynomial going to be? 3. All right. Now, remember what we said in the very beginning? If C is a 0, then what's a factor? X minus C. Nice. If C is a 0, then X minus C is a factor. That means if 4 is a 0, then what's a factor of this polynomial? Then, yes, X minus 4 is a factor. Also, X minus 4 minus I is a factor. Also, X minus 4 plus I is a factor. Now, here's how I do this. You're gonna basically multiply all this out now, okay? But there is a like a slick way of doing it, right? So watch. This is X minus 4. I'm just gonna let that one go for a minute. Just distribute this, and we get X minus 4 plus I, right? And here, X minus 4 minus I, right? Now, associative property says when you have 3 terms, you can group them any which way. So I could put parentheses around the 4 plus I or the X minus 4. In fact, that's what I'm going to do. I'm just going to put parentheses around the X minus 4s. Why would I do that? Because when I do that, what do I have? Well, forget about the first one, but I have X minus 4 plus I, X minus 4 minus I. It's like a difference of squares. If I have X plus 5 and X minus 5, what's the quickest way to multiply those? X squared minus 25, right? I square the first, I square the second, and I put a minus in the middle. Well, look, that's what I just created here. X minus 4 plus I, x minus 4 minus I. So what I'm going to do now, I'm just going to let that x minus 4 hang out for a little bit. Now here, I'm going to take the first term and square it. And then I'm going to take the second term and square it. And what sign do I put in the middle? A minus. So let's see where that gets us. X minus 4. What's the blue going to give me? Ooh. Minus 8x plus 16. Minus I squared will be what? Plus 1. So now I have x minus 4, x squared minus 8x plus 17, and now I'm going to distribute. Okay? Well, I'm going to multiply x minus 4 by that trinomial. So let's do the x first. Everybody in here gets an x. X cubed, negative 8x squared, 17x. Now the minus 4. 4 times 17 is what these days? 40, 68. Yes? So f of x is this 17 plus 32. There we go. We just figured out a polynomial of least degree that has zeros, 4, 4 plus I, and 4 minus I. Okay? This homework is due tomorrow, which is Tuesday.